Hello students. So we will start our ninth video of Maths 9. Okay. So today we will discuss about the real numbers. Okay. So real number. So you can see on the screen that what is a real number? A real number x. Sorry. Okay. Any number x is said to be our real number. Any number x is said to be real number if or when the square of that number is greater than 0, then only we will say that that number is real number. So this type of property is satisfied by natural number, whole number. If you take any natural number, suppose 1 square is 1 and this is number is greater than 0, then whole number 0 square, it is 0, it is equal to 0. So if we see this property, that is x square is greater than equal to 0, so this property is being satisfied by our every natural number, every whole number, every integer, every fraction, all rational number and all irrational number. So all these numbers, that is natural number, whole number, integer, fraction, rational number and irrational number, all these are our real numbers. Okay. So in page number 15, okay, in page number 15, so there is one number system chart. So write it from the book, page number 15. So you have to do that. Okay. So then only you can differentiate the which numbers are your natural number, which numbers are your whole number. Okay. So which are your prime numbers, which are composite numbers. So first if we see it, the real number. So real number comprises of rational and irrational. Okay. And rational number is represented by q and irrational number are represented by root q bar. So rational number we have discussed, irrational number also discussed. In rational number we have again two parts, that is integer and non-integer. Integers are all the positive, all the natural number, all the negative of natural number and 0. These are our integers. And in non-integers number we have two type of fractions, that is our fraction and decimals. So in fractions we have already said that numerator and denominator, if the numerator and denominator are your natural number, then that type of numbers are known as fractions. Whereas in decimals are those which are recurring or terminating. Recurring means the after the remainder will be repeated infinitely, or terminating. Terminating means after finite number of steps we will get the denominator 0. Suppose you are 1.5, you are minus 2.5 or 1.6 bar. So 1.6 bar, 6 bar means your 1.6666 like this. This type of numbers are called recurring numbers, and this can be represented in as decimals. Okay, and this come under non-integral rationals. Fine. So similarly you can see that the integer have three parts. So integer have your what are integers? All the natural number, all the negative of natural number and including 0. So this is our positive integers. Okay, these are called positive integer, this is our 0 and these are our negative integer. Okay, so integers are further classified into negative integer, positive integer and 0. Similarly your 0 and positive natural numbers, positive integers are known as our whole number. Okay, and positive integer natural number are again classified into three categories, that is your odd number. Odd number are those number which are not divisible by 2. Then we have our even numbers, the numbers which are divisible by 2. Again then we have composite numbers, or no, prime numbers. Prime number are those number, okay, in the prime number section. Prime number are those number which are divisible by 1 and the number itself. Okay, numbers are your 2, 3, 5, 7, 11, 13. This type of numbers are known as our prime numbers. Okay, and composite numbers are numbers which have more than 2 factor. Okay, more than 2 factor, like 4 have more than 2 factor. Why? It is divisible by 1, it is divisible by 2 and it is divisible by 4. Okay, so this type of numbers are known as our composite numbers. And then we have our next topic, that is our surd. So what is surd? So to know that what is surd, so let a be a rational number and n be a positive integer such that your nth root, this is written as your nth root of a and it is written as is irrational. Okay, so if a is any rational number and n is any positive integer such that our nth root of a is irrational, then only we will say that nth root of a is the surd. Okay, or it may be written as radical also, and its order will be this one, this n will be its order. Fine. So you can see that two important notes are there. So in note 1 what it is written, that nth root of a is surd, it will be surd only when a is rational. If a is rational and nth root of a is irrational, then only we will say that nth root of a is a surd. Okay, and when a is irrational but your what we can say, that if a is irrational or nth root of a is rational, but if nth root of a is rational, then root over n is not a surd. Okay, to become a surd, a must be rational and root over n a must be nth root of a must be irrational, then only root over nth a will be your surd, otherwise it will not be a surd. Okay, so you can see the examples 1, example 2 and example number 3 in page number 15, which are surds and which are not surds. So it is clearly mentioned that root over 3, so you can see here also in the screen. So root 3, you can see that root 3, our 3 is rational and root over 3 is irrational, so that means root over 3 will be surd and its order will be your 2. Fine, because here it is written as 2, it is 2. Okay, again root 3 cube root of 4, this is your cube root of 4, next one. So cube root of 4, so you can see that 4 is rational number and cube root of 4 is irrational number. Why irrational number? Because 4 is a non-perfect, 4 is non-perfect cube, that is 4 cannot be written as any number which is multiple of 3. Okay, if a number is multiplied 3 times, then we will not find 4, that means 4 is not a perfect cube. That's why our cube root of 4 is irrational number. So as it is irrational number, so its order will be your 3, its order will be 3 because it is 3 here. Fine. So similarly cube root of 4th root of 6, this is also a surd and its order will be your 4 because 4 is written here. Similarly 7th root of 10 is also a surd and its order will be 7. Okay, but you can see this example number 2, that is cube root of 27 is not a surd. Why cube root of 27 is not a surd? Because 27 can be written as 3 into 3 into 3, that means cube root of 27 is answer 3. So here your cube root of 27 is not irrational, it is a rational number, that's why it is not a surd. Okay, it is not an irrational, that means it is rational, it is a rational number, that's why it is not a surd. Again root over pi is not a surd. Why root over pi is not surd? Because to be a surd, you can see the note that this number must be rational, but we know that pi is irrational. As pi is irrational, so root over pi is rational number, so that's why root over pi is not a surd. Clear? Okay, so next we will move to the rationalizing factor, RF, rationalizing factor, very important. So before going this, you have to understand the definition. So if the product of two irrational numbers, okay, if the product of two irrational number is rational, okay, suppose we are taking two irrational number and after multiplying that two irrational number you are getting rational number, then each one means the product of two irrational, the two irrational number are known as the rationalizing factor. Okay, so let us understand this with one example. Suppose we have taken a and b integer and x and y are natural number. We may or may not take the natural number also. So as a and b are integer, suppose root over b is irrational. Okay, here our root over b is irrational number. Okay, so a plus root b will be irrational and a minus root b will be also irrational. So if you multiply these two irrational number, the answer is a square minus b. As a is integer, so a square will be again integer and b is also integer, and integer minus integer is again integer. So integer and integer are rational number. So you can see that we have multiplied two irrational number and the result is rational number. So that means we have got the rationalizing factor. So which one will be the rationalizing factor? Your first each one means your a plus b, root b and a minus root b. So this will be your root. Okay, these two will be our rf means rationalizing factor. Okay, so these two will be only rationalizing factor if and only if these two are irrational and their product must be rational. Fine. So let us rub this. These are just for understanding. Okay, fine. So let us move to the next topic. Let us do the solution of exercise 1D. Okay, so all of you open the page number 19. Okay, so question is rationalize the denominator of each of the following from question number 1 to question number 10. So rationalizing means, okay, so what does the rationalizing means? So first question is 2 by root 6. So what we have to do, you have to here you have to see that our denominator has only one single term. So rationalizing means multiplying this denominator in the numerator as well as in the denominator. So this method is known as the rationalizing the denominator. As the denominator have only one term, so you have to multiply with that term to the numerator and the denominator. Okay, so there are some formulas which I have written in the left side. These are some formulas you need to understand. Okay, so 2 into root 6 will be 2 root 6 and root 6 into root 6. So I have used the formula number 1, that is root over a into root over a. If the square root of any two number, if you multiply it twice, then answer is a. So root 6 into root 6 will be 6. Fine. So this is the required answer. Similarly, in question number 2, you can see that the denominator have only one term, but out of this only root 3 is irrational. Okay, so out of this only root 3 is irrational, 2 is rational. So what we will do, we will multiply the numerator and denominator with root 3 only. Now our numerator was root 2, so root 2 is here, denominator is 2 root 3, 2 root 3 is here, but 2 root 3, out of 2 root 3, root 3 is the only your irrational number. So that's why we have multiplied the numerator and denominator. So here you have to write that rationalizing the denominator. You have to write this. I have not written, but you have to write this. So if you multiply, so root 2 into root 3. So if you multiply two root numbers, so you have to apply this formula. Formula number 2, root over a into root over b. This answer is root over ab. So root 2 into root 3, root over 2 into 3. 2 into 3 is 6. So root 6 divided by, now root 3 into root 3. Again we have to apply the formula number 1. Root a into root a is a. So 2 into root 3 into root 3 is 3. So answer is root 6 by 2 3 is 6. So this will be the required answer. Fine. Now you have to understand that in question number 1 and question number 2, we have in the denominator we have only one term. So what will happen if we have more than one terms? So in question number 3, you can see that the denominator have more than one term. Okay, it have two term. So for this, how we will do? You have to see this sign. If it is positive, you have to multiply the numerator and denominator with the negative sign. That means we have multiplied the numerator and the denominator with this negative, because the positive was there, so we have to change the sign. Only if it has two term, that is 3 plus root 5 was there, so we have to multiply 3 minus root 5 and 3 minus root 5 in the numerator and the denominator, and you have to write this, that the rationalizing the denominator. Okay, so here I have written more formulas, so you have to use this. So 1 into something, this will be same. Again you can see that this was the formula matching to your 6. Example number 6. A plus root b and a minus root b type. So answer is a square minus b. A square means 3 square minus b. B was our this b. This b is our 5. So answer is 3 square minus 5. Okay. So this will be 3 minus root 5. This 2 will be not subtracted because 3 is another 3 and root 5 are both are different numbers, cannot be subtracted, and 3 square is 9 and 5. So 9 minus 5, answer is 4. So required answer is this one. After solving this, you have to see that the denominator is rational or irrational. Rationalizing the denominator means we will convert the denominator which was irrational, we will convert it into rational. So here you can see that 4 is rational, so that means we are successful. Okay, But after that, suppose at the final answer also there are some root number are coming and that number is irrational, so again you have to repeat this method. Okay, so we will solve more questions. So let us move to slide number 7. So question number 4. So you can see that in question number 4, again we in the denominator we have two terms, but here the sign is negative. So what we will do, we will multiply the numerator and the denominator with the positive sign. Clear? If it is positive, we have to multiply by negative. If it is negative, we have to multiply it by positive sign. Okay, so formula will be same. We have to use that formula. In the previous slide I have already written all the formulas. So 1 into something will be as it is, and this is our root a minus b. Here root a minus b, answer will be your a minus b square. So this is a minus b square format. Okay, so if we solve this, so we will get the solution. So again you can see in the final answer the denominator is 2, so that means it is a rational number, so we are successful. Okay, and this is 2. Fine. So similarly in question number your 5 and 6 both are same, so take 5 and 6 to be homework. Okay, now we will move to question number 7. So we don't need to see the numerator, just we have to see the denominator, because we are rationalizing the denominator. So now question is same. So here the denominator, you can see the denominator sign is positive. So what we have done, we have multiplied the numerator and denominator with the negative sign. As this is positive, so we have multiplied with the negative sign. So we have to apply the formula. You can see that these two numbers are same. So if same number are multiplied, then it will be whole square. Okay, so we have squared it, and denominator has the formula same, a plus b, a minus b form. So a square minus b square, it is 1 square. Okay, so in the next slide just open the formula, root 3 minus 1. So root 3 minus 1 whole square and 3 minus 1 square. So we will use this formula, your a minus b whole square. So a minus b whole square is your a square plus b square minus 2ab. So if you use this, a square plus b square minus 2ab. So after solving, you will get the answer, that is 2 minus root 3. So now you can see the denominator, if the denominator is not here, so denominator is 1 and this one is a rational number. So we have successfully rationalized the denominator. Okay, so similarly question number 8 and 9 are also same. So you try to solve 8 and 9. Okay, these two will be also homework. Similarly in question number 9, not 9, question number 11. Now you can see we have more than 2 terms in the denominator. So if we have more than 2 terms in the denominator, you have to put one bracket which consists of 2 terms. So either you can put the bracket here and take root 2 plus root 3 as a single term, or what else you can do, we can take the bracket here also. So we can take root 3 minus 5 as a single term. So it's up to us that what we have to do it. Okay. Okay. So we have taken root 2 and root 3 in the single bracket. So root 2 plus root 3 minus root 5. So you have to treat this a minus b like. So as negative sign is there, so we have to multiply with the positive sign. So this is the positive sign. Okay. So now here you can see that root 2 is multiplying with root 2, root 3 and root 5. So root 2 into root 2, this is 2. Root 2 into root 3, this is root 6. Root 2 into root 5, this is root 10. Okay. Again in the denominator, if we see clearly that, so let us rub this. This is of the form of, this is a minus b, a plus b. So we have the formula, that is a plus b into a minus b. The formula was our a square minus b square. So a square, this is a square minus b square. So after solving this, here you have to apply the formula of a plus b whole square. The formula is written in the top, a square plus b square plus 2ab. So after applying and solving, we will get the answer as this one. Okay, but after getting the this one or this, this one. Fine. Now solving this, we have got the answer as this, the final answer. But if you see the denominator, root 6 is still there, and we know that root 6 is irrational number. That means again we have to rationalize the denominator. Why? Because our denominator is again irrational number, but we are rationalizing it. So but the denominator is not a rational number, so what we have to do, we have to again rationalize it. That means as root 6 is irrational and 2 is rational, so we have to again multiply the numerator and denominator with root 6. So we will multiply it in the next slide. So that's why you can see that we have multiplied it by root 6 on numerator and denominator. Why? Because 2 root 6 is still a irrational number. So again this root 6 will multiply to 2, to root 6 into 2, 2 root 6, root 6 into root 6 it is 2, root 6 into 10 this will be root 60, and root 6 into root 6 this will be our 6, okay, using all the formulas. So after solving it, so root 60 can be written as your 2 root 15, okay. So taking 2 common from the numerator, we have got this answer. So in this answer, you can see the denominator is 6, that is rational number. That means we are successfully rationalized it. So this will be our final answer. Fine. So in the next video, we will try to cover all the other question left. So till then, practice all the question, and if you find any difficulty, then ask me, okay. And it is advised to complete all the homeworks, as well as you have to see the solved examples in page number 16, 17 and 18. And if you find any difficulty in the solved example also, then you can reach me, okay. Thank you.